would say remember me, but some of you may not even know me. If you don't know me, I'm the interim dean, John Kesbairn. If you do know me, I'm still him. But it is my great pleasure to introduce tonight's speaker, Frank Barco. I've long admired the work of his office, Barco Leibinger, which he founded in 1973 with his partner, Regine.
93. 73 would have been nice.
What did I say? Oh, 93.
I was still in junior high.
I have it correct, yeah. Just, you know. But I was wondering if the pronunciation, Regine.
Right, correct.
What is striking to me is how each building is so different from the next, reflecting the approach that each project is unique in every way, from context to client and users to budgetary constraints. However, what is common to all, in my view, is a research-based application of and experimentation with technology, building systems, fabrications, juxtaposing unexpected materials and structures. And I think an example of this, which I presume we will see, is the recently completed Harvard Art Lab. Their office is committed to academic teaching, research, and professional practice, each informing and enriching the other. The firm has won so many significant international awards, impossible to mention all of them here, exhibited at many international venues, including twice at the Venice Biennale, Chicago and Marrakesh Biennales, and the work is in the permanent collection of the Museum of Modern Art. Frank received his Bachelor of Architecture from Montana State University and his Master's from the GSD Harvard, where he met Regine Leibinger. He has toured at numerous institutions, including Princeton, the GSD, and the AA in London. The Rice projects include the new Sid Rich College, which is now under construction, and a new wing for Hanson College, replacing the 1957 wing, which is designed to use mass timber construction, and importantly to us, this was facilitated by the award of a $100,000 grant from the federal government that our very own Jesus Pasayo and Albert Pope applied for, and others, and which will go toward funding the planning and approval process of the building. So we have some connections to that too. One of my pleasant duties as dean this year is to serve on the Rice Board's Buildings and Grounds Committee. I guess it's called the Design Committee too. I'm not sure which, but I go to these, and it's very nice, where I have already seen the exciting preliminary proposals for Hanson, and I look forward to seeing the building realized. One last word, and there are members of the committee here, so I think this is true. I've seen firsthand how architects are selected for projects on campus. Once a list is finalized and the architects interviewed, a few firms are singled out to visit, as was Barco Leibinger for Sid Rich. And I've heard, and the members can attest, that as soon as the committee set foot in your office, they knew right away that you were the right architect for this job. So please help me welcome Frank Barco.
Thank you, John, for that wonderful introduction, and it's great to be back with this ongoing process. In the resume, you forgot to mention, I was talking to Raym about this a little bit earlier, that I actually started as a carpenter in Great Falls, Montana. So this is a little bit coming full circle for me.
Can you speak up?
Yeah, am I plugged in? I think I am, but I will speak up. thank you for the introduction. I think this idea of toolbox, or the way we work in terms of fabrication, material, tooling, is an important way how we work, and I think the visiting committee going to our offices would be a way of experiencing that in terms of focusing around our shops, our model shops, our workshops. So that's always been an important way for us to work. I'd like to welcome some of the people we've been working with here. I think Kevin is back here, and Brock Science we've been working with closely in this process. Kirksey Architects, you guys are here also. So this has been a fantastic process for us. I think Rice, for us, was always an incubator for architecture, historically, always looking for what's next in architecture. So it's fantastic to be part of that ongoing context. So we're very happy to be here. I think also, as John said, this idea of differentiation in our work, how projects can change, how the practice can evolve is important for us. So I think we do think of architecture both as a practice and as a form of research, and our teaching as a kind of area of research that can continue. It's something we can react to and think about. So the lecture tonight, I've sort of broken it up into certain work areas. Fabrication, this idea of experimentation and making in the practice is very important. When Regina and I came to Germany in the early 90s, we started building factories. Those were the first projects that we did, and working for factories. We learned about their technologies, machine tooling, laser cutting, both, I think, within the high tech, but also within the low tech of industry. So if the chart on the top is maybe how we worked as students in graduate school, I think below would indicate how we would start to work in terms of identifying materials and tools and how that might drive an architectural outcome. So, and one of the great things about a place like Germany is working with industry. So over time we worked with different companies in different materials. They were keen to see applications for their capabilities through architecture. So this is an ongoing process, but in a way it was a shift from when I was a young architect in the States, where we would work out of building catalogs, to the opportunity to work and, in a sense, produce our own components for architecture through fabrication technologies. A few years ago, through the Architectural Association, started to produce these so-called atlases, where we would catalog not so much any particular building, but building processes, applications, more about processes of making architecture rather than focusing on individual buildings, and starting to produce these kinds of archives. So in this exhibition, you would see offcuts, components, ideas about structure, ideas about facade, surface making, through different production capabilities. We would work closely with students in our practice, would go down to Stuttgart, test machines such as this laser cutting machine, or looking at producing space frames on the right through concrete or steel construction, and how that might work in our work, or find a place in our work. I would say 15, 20 years ago, we stopped showing models and drawings as a form of exhibition. Representation started making installation scale work. This is an installation in Berlin, where we laser cut plexiglass tubes into these bundles, started using scripting technologies. But the idea that an exhibition could be something spatial, could be something experiential, something that you could move through. At the same time, we were interested in the aspect of history in architecture. This is a hangar produced by Konrad Waxman in '51 as a large space frame structure. We were interested in revisiting these kinds of projects through our own work. This is a sketch on the right from Konrad Waxman called Grapevine Structure, which is a structure which is in the drawing spatial. You could imagine moving through a structure such as this. For a pavilion, a kind of pavilion in southern Germany in a vineyard area, a series of pavilions on a 100-mile path where we produced a lightweight steel space frame with Werner Sobeck using a similar idea to Waxman of intertwining or weaving steel together to make a lightweight structure. So these kind of pavilion scale projects, which are small and maybe diminutive in scale, are for us kind of prototypes. This could be a project that could scale up, could work at the scale of, say, a factory. So as an area for experimentation, it was very important, or also the idea of testing the limits of materials. These are tessellated bundles of 2 millimeter stainless steel wire. We worked with a coat hanger fabricator in Munich who put these together. We tried to weld them. It was too complicated. We ended up zip tying the whole structure together. So as a site for experimentation in a project in the future that we're looking at, this will scale up. We'll produce a large span space frame structure for an industrial exhibition hall for this. So again, the importance of these smaller pavilion scale or installation scale projects is their capacity to scale up. So in Mark Lee, Sharon Johnson's exhibition, they curated the Chicago Architectural Biennale a few years ago. We did a proposal for 3 towers for Berlin for affordable housing, one in Infolight concrete, the pink one, timber construction as a high-rise, recycling pine logs in Berlin, and a metal one in the background. So we were looking at history such as Tesseno's Festhall from 1936 as a version of an architecture which could be stacked into this high-rise made out of timber construction, again, or a high-rise created of Infralight concrete. This is a self-insulated concrete which we can stack like a house of cards I can show in a minute, or a tessellated structure created out of these bundles in a similar fashion to create prefabricated and quickly constructed high-rise housing for Berlin. Another example, at this pavilion scale would be for the Serpentine summer houses, where we produced a loop structure. At that site historically was a pavilion by Robert Wren, which rotated 360 degrees on this artificial hill. We went back to our shops. This is our workshops in the studio. We produced dozens and dozens of sketch models, brought these over to Kensington Gardens, proposed and presented them to the curator, Julia Peyton-Jones, where she was able to select one quickly as an idea and model, which almost immediately translated into these shops. Harrier bomber hangars in Yorkshire in England, where we translated the models into a lightweight steel structure, which was then clad in a bendy ply plywood quickly and economically for a temporary pavilion. So these loops are stacked over each other from the scale of furniture. You can sit in this as a temporary structure with a large overhanging cantilevering roof over it. So again, as a kind of prototype, this is a project which we could imagine scaling up to the complexity of a large building. It could change its materiality, its scale. So as an experiment for a temporary summer house for the Serpentine Galleries, but a project that has a kind of currency for future projects. In the same way, this loop hyperbolic project we did is an installation next to the Kutubia Mosque in Marrakesh. Marrakesh has no Museum of Modern Art per se, so this was an opportunity to make art installations a public place for encounter, for people to meet, to move through. We produced or in a sense designed this project once we knew which site we had in our studios in Berlin, through more complex computer models, and then made physical models in our shop. So then the task in a way was to translate our models through that building culture, which was a fascinating one. I mean, we literally brought the materials on site with these carts pulled by donkeys. We worked with local weavers in terms of how to fabricate skin for this. The timber and steel joints were made in nearby souks. Mohammed was the foreman for the project, taught us how to weave, how to produce this project in 2 weeks. How the night tiling. So this idea of taking a kind of maybe more abstract geometric computer model and then filtering it through a very specific building culture was really a fascinating process for us, how to produce a large-scale installation. Again, this idea of a project that may have a kind of future life in projects to come. So this is a kind of installation you could move through, you could walk through it, you could walk around it, you could meet people that work at different scales. So we'll open opera. Fidelio is Beethoven's only opera. It's the 250th anniversary of his birth. This will open Vienna in 2 weeks, so this is sort of a sneak preview of that opera, which will be directed by the actor Christoph Waltz. But in this case, producing a complex geometry, a kind of double helix, which is morphed together. We studied it and made many iterations of this in our studios, and then produced this as a timber construction off-site in Poland. So we constructed it off-site as kind of prefabricated structure. Then we take this apart in components and almost like a ship in a bottle, construct this inside of the Theater an der Wien, which was the site of its original performance. So it's a kind of architecture for opera, which means it's porous. Singers can move in and out of this. They can sing individually or in groups, but an architecture that came out of our fabrication capabilities, but used for opera. If you remember the libretto of Fidelio, it's a prison. So in a way, this is an idea for a kind of Pyrenean space, but interpreted through new materials and with a new geometry. So, and I think John mentions this in the beginning, but constantly looking for very different opportunities for what architecture is, what it could be in terms of scale, in terms of program, and in this case, a kind of performance. Another area that we're working in is facade, and maybe liminal is a fancy way of saying the idea of the facade is a kind of mediator between a kind of private world and a public world. Also, the idea of the facade is something that's performative in terms of, say, sustainability. The facade is where we have the most likelihood in terms of controlling that kind of performance. It's also the idea of the facade being the thing that usually determines the appearance of a building publicly. So we started to shift, I think a few years ago, 10, 12 years ago, from industrial projects to more urban projects. So in Berlin, we produced a tower for Tour Total, for the French energy company, producing a facade created out of fabricated concrete. Through our fabrication capabilities, could produce complex formwork. Because of digital capabilities, we could produce, I think, 160 different components for one building economically, and the idea of producing a kind of deep facade that has to do with sun screening, exterior sun shading, windows that are operable, that open up, that at the same time is quite dynamic, very plastic facade, three-dimensionally. It's quite animated, but as a way also as an idea of a kind of sustainable facade. Again, de Blasio, the mayor of New York, recently saying glass facades are forbidden in New York. So this idea of a more material facade, a facade with depth. We also like the idea of contradiction. In this case, this is a stone facade for a nearby second office building we did, but a curtain wall, which is a non-load-bearing facade, but in a very fine scaled stone, which articulates this particular facade. We'd done things earlier, thinking about facade again as a kind of mediator. Earlier project in Korea, which is a facade that would never have been allowed to be built in Germany. It would have been cost prohibitive. By code, you couldn't build a facade like this. So we produced, the glass was cut in Minnesota, the frames were built in Korea, but the idea of creating reflective low E facade that works like a kaleidoscope, again, responding to a place that for us had almost no context, a kind of instant city on the periphery of Seoul, so that the building would respond visually to anything that would be built around it, cars, changing weather, traffic, using the components of the glass we could get from Minnesota, marrying that glass to these frames, discovering with a very low sort of spatial depth that we could get an enormous amount of visual effects. So one of the things we did was start doing mock-ups in our studio. So in a way, you're looking at a pixelated image of our studios in the background that we discovered through very slight sort of inflections in the glass that you get an enormous amount of visual effect through that. So, and we realized that the facades could be either reflected, very dynamic this way in the nighttime. They become transparent, also combined with these shadow box glazing sections here. But which is only to say that all of a sudden, I don't know, so 10, 15 years ago, we discovered that we could fabricate major components of our buildings not as pre-existing systems, but some systems that we, again, researched and found ways of producing, found partners in Arup, engineers in Hong Kong to make this happen, working with local fabricators. So this idea of going someplace like Morocco or going someplace like Korea, landing on the ground, seeing what the constraints are, seeing what the opportunities are, and exploiting these very, very different building cultures for producing projects that, again, would be very different from place to place. Again, this idea of differentiating the practice through these kinds of projects. More current projects such as this multi-story parking, it's a parking lot, it's a parking structure. It'll be the largest parking structure for electric cars in Germany. It's a building that can transform into an office building when cars go away, which will terrify the Germans, but it's going to happen. So we used prefabrication on site, laser cut tubes. Again, you saw some examples early on. And then married that facade to a completely off-the-shelf concrete and steel structure for parking structure. So this is kind of a place where I'm quite interested right now of using these kind of off-the-shelf systems, modifying them in terms of plan and section, modifying them in terms of section, and also programmatic modification where a building like this could transform into loft spaces at a future date. So this is an interest in concrete steel. It's certainly an interest in some of our work with timber, such as what we're starting with here. The Walls project is, this is again a project we're working on this week, so some of this work is very current. This is a project which has to do with casting. As you know, Berlin is a city built on rubble from the Second World War. One of our ideas was sand casting, but instead of casting with sand, we were casting with rubble to produce this wall, which is a kind of top view down, which we're doing for an exhibition at the Haus am Waldsee in Berlin. So it has a kind of textural idea in terms of sand casting or, in this case, rubble casting. It's also has a future as infilite concrete. We can pour this in a self-insulated concrete. So in a way, these could be thought of as prefabricated pieces for another application. Again, for example, an office building, we ran one around the corner from our offices. It's a radial plan, which is intended to have a kind of broken concrete facade for this building. So almost ongoing, the kind of research between the pieces we're building in these exhibition scales to often almost an immediate application in terms of the building projects we're doing. So it's Europe, so we're constantly doing architectural competitions and using the research as a way to, so these would be variations of that facade in a broken stone or broken concrete production. So a kind of relationship, almost immediate relationship between the kind of research projects and finding applications of it. In terms of ultra-structural, there's also been an ambition in the practice where the structural idea is the architectural idea. We work with structural engineers, sustainability engineers up front in a workshop process so that those ideas are part and parcel. This was a workshop with Werner Sobeck, who's a Stuttgart-based engineer, and he's the successor of Frei Otto. So he was interested in these kind of hierarchical structures. The models on the left were made with students, testing ideas for timber, testing ideas for concrete, testing ideas for steel, to the more sort of digital shop drawings on the right, which was how we ultimately constructed these things. So there's a kind of direct immediacy between the kind of sketch model, which is how we typically work, already thinking about, even at those early stages, its constructability, how you would build these things, how you would translate them. The project is constructed like a leaf over an excavation. This industrial campus is tied together at the tunnel level. So we did an excavation like an amphitheater and then placed this roof over it. So again, these are one of these projects where we started constructing or fabricating the entire building through our own, in a way, inventions. This is a production shop in the Black Forest where our information was fed into computers. The components are digitally cut off-site, then brought on site, and then quickly put together. We combined a steel sort of mainframe for the structure with glue laminated CNC cut construction where every piece is crafted together. They're highly precise. Each joint is unique. So this was a project that even 5 years earlier would have not been possible for us to do. So we could produce a project like this, a kind of flexible, large space. It's a cantina, which in a German company usually means a horrible cafeteria in the basement somewhere. We wanted to create this as a kind of event space where music could be played, lectures could be given, people could meet, people could exchange ideas, the breaking down of blue collar and white collar work. The honeycomb roof is something we could program. We could program it for skylights, for daylight, for artificial lighting, for acoustical cells. So it had a kind of performative idea as well as a kind of formal spatial aesthetic one in terms of creating this roof. So and this project I think is about 2008. So this was kind of an exciting moment where we, the precast concrete, the ceramic tiles that we produced for the project were done nearby in a complex structure. So in a sense, the idea of ultra-structural is that the structure is the architectural idea as well as the actual thing that's holding itself up, that those ideas coincided. It's all exposed structure. It has a kind of performance in a flexible floor plan that can change as and also as a kind of social building for a factory where everyone could meet, an outdoor terrace facing the south, where people could meet and again discuss ideas, discuss the machines that they're working in, the things that are producing. So both programmatically, a different kind of building for a factory and a different kind of way of meeting. At the same time, we did a gatehouse, and in a way, this project was the first project where we used their technology completely. Again, laser machine tools for cutting metal. We discovered that they were making everything from tables to ship decking out of laser cut, laser welded sheets of metal, and our idea was to scale this up to the scale of a building. So, and at the scale of a complex building with a large cantilevered roof. We took Sobek's structural drawings and then began to translate those drawings through this sort of box frame truss. We produced it again off-site, brought the pieces, these strips to the site, fabricated and assembled them together, then lifted the whole piece up on these 4 columns. So like the roof of the National Gallery in '68 in Berlin, you had like all 2,000 people in the factory to come out and watch this thing get lifted up and dropped onto these columns. It worked, so we were quite happy about that. But again, a laser cut thing, we produced a facade, and I think in the interviews I was doing this morning, combining, high-tech laser cut this, but at the same time the facades were made by artists, by craftsmen. In this case, a facade made of a double glass, a facade entirely made of glass with plexiglass tubes that are fitted between a double layer of glass to produce this really beautiful kind of very ephemeral facade for this building. So again, all of a sudden we produced everything for the project as a representation of what this company does, but also as a form of research for ideas about facade making, about structure, etc. Some of the projects we haven't built but are again, using structure. This is a project which I like, which I haven't been able to, it's on the boards, it's on my to-do list, but it's a project for catenary infill. So there are many sites in Berlin which are simply holes in the fabric of a block, buildings were destroyed during the war. These are infill projects. They can be wider, they can be taller. It works as a catenary. These are prefabricated boxes which are for housing. The space in between can be used as workshops, as studio space. The buildings can be higher. The depth of the building can also change. So there was an idea of, again, a kind of programmatic prototype where we're looking at sites as a developer where we could produce and build a project like this out of timber and steel construction, having identified dozens and dozens of sites like this around Berlin. So we like to do this where the project isn't so much a kind of response to a kind of client brief, but more as a provocation or a question in terms of how we could actually operate as architects in a place like Berlin. So this was also in my interview this morning a discussion about practice. So I think we're also becoming very interested in the idea of developing projects and seeing them executed in places like Berlin. Other projects at the kind of very gritty low end, I think, versus projects like this for the American Academy in Berlin for the Arnold family, which has a villa from the 19th century. They asked for us to create a kind of very beautiful pavilion in their park, their sort of gardens, which face the Wannsee Lake. Which is this incredibly beautiful site along the lake. So we produced this pavilion over here, using sort of the knowledge that we gained in Marrakesh in terms of how you can produce ruled geometry, structure, in this case a prefabricated steel construction to produce 7 study carrels within this space for scholars who come to Berlin to learn. But also maybe like the Stuttgart project, the Cantina project, again, the roof as a way of organizing these spaces. So again, switching scales to a very small scale project, but with a high level of detail in terms of its execution and precision for scholars. So this is Beatrice Colomina, Mark Wigley, old teachers of ours, who were the first guys to move in here, which was quite charming. It's a place where you can retreat and work, close the curtains and you can work, or if you're more social, you can open the sliding doors and hang out on this porch. So for me, it was also a kind of American typology, a kind of American building for scholars to work in. So again, this kind of shifting in scale into a building like this. The smart materials houses, I kind of introduced this in the Chicago, but this was an important sort of research area, and it's an ongoing research area. We were asked to use a smart material for the International Building Exhibition in Hamburg about 10 years ago. We worked with our engineer, Mike Schleich. We knew that there was this amazing history for Plattenbau or prefabricated concrete in Eastern Europe. This is Khrushchev overseeing a model about how this vast housing project could work and did work, was implemented for housing through the Eastern Bloc of Europe. So again, thinking historically, we were asking ourselves, what's a smart material? And how would you use it? How could you revisit a project like that and make it a contemporary one? So we work with Mike Schleich. He introduced Infralight concrete to us. It's a concrete which is insulated. The aggregate, the little black dots are clay or recycled glass. If you put this block in a bathtub, it'll float. So it's kind of like lava, but it's still structural. The thicker you make it, the better it's insulated. And then combining it with timber construction. So we built large-scale models in our shops to see how this would work. And I would say work intuitively, how structure actually works. So we made these pieces sculptural, so they would be spatial. We made them also sculptural, so they would be self-supporting. They would stand on their own. We wouldn't need scaffolding, and you could stack them up like a house of cards, but like pretty thick cards. So, so that's what they could do. They could produce these exterior spaces. It's again intended for low-income housing. Each unit, even no matter how small they are, they have an exterior balcony. We could combine this with timber decks and timber windows as a system which can stack. So in this case, the stacking is offset because we have no cold bridges. The pieces are scaled to what I would say kind of domestic or residential scale. We had 2 or 3 different types. You can flip them upside down, and then you have a second type. But all of a sudden, you know, going away from modernism, which was all about lightness, like steel, lightweight glass, to walls that could be very, very thick, which would condition how light comes into a kind of loft-like space like this, which had a kind of, for us, a kind of beauty that had really disappeared for, I don't know, maybe 200 years or something. And then combine these almost Baroque plans with a very matter-of-fact, you know, 9-square core in the center of concrete. So you can live in a very open fashion. You can cordon it off, make rooms if you like rooms better, but a very flexible system within a kind of basic set of rules. Like in other projects, when we had the chance, and in this one we won a prize through Holcim, a Swiss concrete manufacturer, that allowed us money to start testing our own prototypes of this. So what it would look like, the quality of the concrete, in terms of insulation value, how all of these things would work as a kind of, in a way, a kind of invention. So with that, we've gone forward to produce, we're building a high-rise tower for affordable housing in Berlin in the context of these Eastern Plattenbau. This is the Karl Marx Allee, In the high-rise condition, the structure is in line, it's not offset. And what we discovered, and this was also a studio, what we did with our Harvard students was, this is Berlin, this is a city desperate for housing and affordable housing. How do you do that? What are the conditions? What are the conditions of legislation where housing can be infilled? We discovered dozens of sites where point towers could be built within this fabric without negatively impacting the neighbors in terms of light, view, orientation, as a kind of viable, both viable in terms of economics, both viable in terms of production, how you make it, and viable programmatically in terms of providing affordable housing for the city. Again, in the shadow of this huge influx of refugees coming into Berlin, 1.2 million in the last few years, the kind of imperative for doing that. So technology in response to a kind of social programmatic issue based on economics. So that's a kind of path of research that we're just now starting to implement in terms of a kind of construction project in Germany. In the meantime, and I've been pushing for more and more work in the States. Again, where I started working again as a young carpenter and later as an architecture student. How do you work here? What are the possibilities of working stateside? What are the differences from, say, Europe or Asia, and how it could work? So we did a so-called Smart Factory in Chicago a couple years ago on a strange site. This is an abandoned AT&T headquarters in this kind of strange Baroque garden master plan here. They sold parcels to us very economically. The parcels are for a German machine tool company. It's close to the airport, O'Hare, so clients can fly in from the Midwest. They can go out to see a smart factory. Smart means for them Germany 4.0, which is machine tools which are digitally connected as well as physically. So an array of these machines could produce something like a John Deere tractor. So the idea was clients could see how these systems work. They can decide what they need. They can buy these machines from this fabricator. The machines are visible to the highway on one orientation. The other orientation is the wetlands behind them. So we produced a building in steel for us, particularly in a place like Chicago, where German architects like Mies van der Rohe had worked at IIT campus, the McCormick building there. In Chicago, they can do steel very, very well. The timber cladding came from here, from Austin, which is a charred cladding, but the construction of this was, I think, $250 a square foot. It's very economical. At the same time, a certain level of experimentation in it. So this is this column-free factory. These are arrays of machines. This is a courtyard, auditoriums, office spaces, cafeteria, the wetlands over here, and the entrance over here. So it's a building. Again, it's still a factory, which means we can, if we need to, we can add on to it. It's a building that will come apart. It can go back together. We did it in Core 10. This is the timber cladding for the building. Everything is exposed. We produced a chandelier using their technology in Red Hook, Brooklyn. So like creating, fabricating all these pieces all over the States and then bringing them in to this building, which we built like in 14 months, very, very quickly, using these kinds of capabilities. So again, it's a building we would never do in Switzerland. You would build in concrete, but in the States, they can do this very, very beautifully. I think the level of craftsmanship was really encouraging, and with the kind of focus on using, again, demonstrating their technology. In this case, our structural engineer, Helbig, who has offices in Stuttgart and New York, we looked at a historical component of structural engineering, which is a Vierendeel truss, and a Vierendeel truss is orthogonal. There's no diagonals. So what I liked about that is it's a structure that's permeable. You can walk through it. So we have a catwalk for customers to see the machines below. We have exhibition, a little auditorium up here. It's a space that can expand to, but almost like that grapevine structure from Waxman, the idea of structure as a space that can be moved through. So the trusses were produced in 3 pieces in Atlanta. They were trucked to Chicago and put up together on site and lifted up so that from above the machines can be seen. So again, this is components for that company using their machines in job shops in Atlanta very economically, very quickly, and then shipping them on site to produce this structure. So in a way, structure as space, structure as the main architectural component that also has a kind of historical alliance with this history of Verandil truss making and rethinking that in a contemporary fashion. So this is the factory from the highway, which is highly visible. The machines can be seen. The kind of activities inside the factory can be seen. So this is a huge shift from, say, industrial fabrication in America now, which is typically big box architecture on the highway. There's no transparency to these buildings. The activities are usually not seen to that. So with that logic, I think like a year later, we did a project for Harvard. Harvard knew that we had done industrial buildings. They were interested in a so-called art lab, so we had to design a small building for Harvard, but we also had to design the programming. So in a way, Harvard's moving from their historical Harvard Yard out to Alston across the river where they have lots of space. And unlike Rice, Harvard has done fairly little construction in the last 20 or 30 years. So this, with their new science center, is one of the first new projects. It had to be done economically, quickly. It's a building that's temporary, which doesn't mean we tear it down, but it's a building that we can deassemble. We can move somewhere else if they need it in a different location. It's lightweight steel construction and polycarbonate. Also for Harvard, it was important that it's net zero energies, which means this building produces all of its energy through photovoltaic cells on the roof, and programmatically a kind of meeting place. So in this building, dance happens, classical music, contemporary music, fine arts, film editing. All of these sort of program spaces were up in the attics of places like Seaver Hall, can come here and now consolidate. So this is the building, which can also expand into exterior, so-called art yards. We could pull up a food truck and make this work. But as a kind of incubator for interaction, performance, exchange of ideas, overlap, and in a way we designed this building, but at the same time they are sort of designing the programming for it, which is unpredictable, how they use it, who comes in, who are visiting artists that can use this thing. The building has an identity, which obviously is very different than Harvard Yard, and is flexible. So there's a shop space in it, there's a kind of hub space in the center, which can be used for performance, for dance, et cetera, cafeteria, all within a kind of steel, polycarbonate, glass structure, which is again constantly evolving in terms of how they use it. It's only been open for about a year, so they're just starting to find different ways. But again, for me, a kind of off-the-shelf structure, nothing really as exotic as some of these other projects, but somehow okay. I mean, for a building like this, which could come apart, which can move in terms of its configuration, which leads me to the projects that we're doing here right now. We came into an interview process a couple years ago with Sarah Whiting, brought us in, ran into her in Chicago, and she asked if we had done any timber buildings, and we said, sure, we've done a bunch. So as a kind of area of interest. So we're working on Hanson. This is actually the second project that we're working on, which is basically, as you know, residential colleges, dormitories. It's a building sited here. We're working also on Sid Rich, which I'll show in a minute. And the two projects have very different considerations in terms of their setup. In Hanson, we're replacing a residential wing from the 1950s to, in a sense, reform the Hanson Quad here. The Weiss Commons over here is a Silvetti Machado project from, I believe, the 90s. So how this project can generate beds, like housing for the campus, and reform the quad, but in timber construction, which I believe will be the first building on campus in prefabricated timber construction. So it's a milestone, and I think also will be a kind of pilot project for other universities to see this kind of a project. At the same time, how do you mediate this within a very particular, very important context, the Rice campus and university? So the idea for fitting this building in was to start with a volume, sliding those two volumes against each other, split level in a sense in terms of the massing, to scale the building down to the quad side, to have a higher scale to the back towards Main Street. So kind of shifting, adjusting the building to fit within that. So the idea of its construction, or the decking, will be prefabricated CLT, timber, plywood decking for it, with a post and beam column and beam structure to hold it together within this long kind of bar-like structure. So this is the massing of the building, which responds to Weiss behind it, to the quad, this kind of shed construction over here to produce, student housing for a building like this, which then, this is the Grove right out here, which it responds to. So a building that sort of mediates between the residential bar from the 1920s, the pieces from the Silvetti Machado, the idea of the quad as a kind of ongoing idea about landscape and a common space for the dormitories. At the same time, going back to the historical cladding of these materials, which is the St. Joe brick. We went to the St. Joe factory in New Orleans, which is a brick factory that looks like it's about 300 years old, but incredibly beautiful in terms of handmade bricks. So the idea of cladding a building like this in a kind of shingle application on this facade, at the same time as a veneer over a massive timber construction, I think is an interesting one. Maybe counterintuitive, but an interesting marriage for us in terms of a historical material with a more contemporary or forward-looking one in terms of sustainability, lightness. So I think that kind of dialogue between these two kinds of conditions is really an interesting one for us, and at the same time producing a building that's robust. I mean, you can really kick it around. So the interiors are a kind of plywood construction, timber floors with a kind of concrete topping on them, again with a kind of brick veneer on the outside. So this building is at a kind of schematic level. We start to articulate ideas for detailing the building, how you construct it. But I think with the possibility of being very appropriate in terms of the kind of social spaces this makes, because as you know, all these colleges here, each one has its own identity. They're quite strong. How this can play out through this kind of construction and the spaces that it will produce for a building, again, that can be produced quickly and economically, something we're continually to work on, that are also flexible with the down view in terms of the model, in terms of how one lives, how one works, studies, cohabits in such a space, how that can work within this campus. So that's some of the ideas for Hanson. We're much further with Sid Rich. I was over there today on site, where we're up to the second floor in terms of pouring concrete. Because this is high-rise construction, we were not able to do timber construction for this one, but I think it's a very, very different building in terms of its situation and what the opportunities are, what we needed to do for the building. So Sid Rich, which is replacing its historical tower from the 70s, really is a kind of architectural ensemble of 3 volumes, a kind of high-rise component here, a lower-rise for housing, a common space is here with an outdoor terrace next to the Grove, an entrance over here. But for us, urbanistically, it was important for this building to mediate between the scale of Main Street with the high-rises from the medical center over here to the existing Sid Rich, all the way to the scale of the quad that this is defining. This is the Grove over here. So the idea of articulating this, relatively, larger building for Sid Rich as a residential college was to create an ensemble. The geometry of the large tower is parallel and aligns with Main Street, whereas the lower volumes align with the quad. So the building really does mediate between those 2 conditions as a kind of hinge between the city and this beautiful campus, which is made of individual buildings and landscape and quads. So that was the main task to do. We also looked at the articulation of surface. We had done a tour around America, had found beautiful modern buildings in places like MIT from Alvar Aalto, who used brick for the famous Baker dormitories, but the idea of using this St. Joe brick, but in a kind of collage, some of it's organized vertically, some of it's organized horizontally. The facade is serrated, so there's a kind of 3-dimensional plasticity through the facades. We're creating through MBK ceramic brise soleil for the facade here. The brick at the lower register is 3-dimensional in terms of how it's produced and laid. So I think for us it was a kind of exercise in brick, but I think in a contemporary way, how could you think of brick as a cladding, in this case on a concrete building, but how could that brick be both materially profound, it's handmade, its color, which is polychromatic, and its texture, which can be flat or it can be articulated in a kind of sawtooth, which we're articulating in the lower ones. And how can that contribute to a complex building ensemble of 3 volumes to define a kind of space for a school that can have its own identity that can, again, sort of act as a hinge between the scale of the city, Main Street, and the more intimate scale of the campus at the quad side. So this is on site. We did also have, in a sense, the luxury of producing generous spaces inside. This is a common space, which is, in a sense, the core, the heart of this building, which we hope will act as a kind of flexible common space, place to meet and hang out in concrete structure, combined with wood timber in detailing. So complexity to this large scale roof terrace with a steel pergola, which looks out over the Grove. So in a way, both these projects are quite different in terms of their ambitions, but allowed us a lot of opportunity in terms of comparison, in terms of how we would approach, in a sense, housing on a campus like Rice. So I think that was the last slide. But what I wanted to do with this lecture is kind of show you a cross-section of how we're working, what we're doing, what the priorities are in the practice, again, how that how we negotiate something at the scale of a sketch to a kind of experiment, to something more physical, more precise, and how we think about that in terms of, again, differentiation of our architecture and the things that we do. So thanks again for the invitation. It's fantastic to be back here, and I hope to see you all again soon. So thanks again.